Hello class, today our topic is projectile motion. So let's discuss what is projectile. So projectile we can understand by term as projectile is an object which is thrown upwards and it gains flight when it is thrown in the air. For example, let's suppose any object which is thrown in the air at an angle theta with the horizontal, so it exhibits projectile motion. Here this is projectile motion, and the path of the projectile motion is known as the trajectory of the motion. The crux of the matter is the trajectory of the projectile is parabolic in shape. Let's understand projectile motion step by step. First of all, in this graph of projectile motion, we have an object which is projectile. Let's suppose it is a ball which is thrown upwards in the air and it exhibits projectile motion. It is its initial velocity u, and it is the horizontal components of its initial velocity, which is u cos theta. As we can infer by this term that cos theta is equal to u upon this y. So u cos theta is the horizontal component of projectile motion, while u sin theta is the vertical component of projectile motion. It's y-axis and it is x-axis. Now let's obtain the equation of parabola, but firstly we will think about some terms such as time of flight, time of ascent, which are the two most important components of time of flight, that are time of ascent and time of descent. The relation between time of ascent and time of descent is that both of these times are equal, because the projectile motion exhibits a parabolic path and the parabolic path is symmetrical on both sides. So we have same magnitude of time of ascent and same magnitude of time of descent. It's our first term, which is time of flight. Now let's move on to second term, which is horizontal range. And the last one is maximum height attained by the parabola, the projectile. Maximum height obtained by the projectile while exhibiting parabolic path. Let's first move on to obtain the equation of this projectile motion, which is parabolic path. Now I have an object which is projectile and it is thrown upwards in the air. It exhibits such type of path. So let's first obtain the equation of projectile motion. We have velocity of projectile on y-axis, which is final velocity, which is 0, and initial velocity of projectile on y-axis is u sine theta. And now if we consider the projectile has traveled x distance in x-axis, on x-axis, so we can infer the distance as distance may be x and the speed is u cos theta, which is in x-axis, and the time is t. So Sy, the distance traveled in y-axis, we can write it as uy t plus half ay and t square. So we can write t as this, while ay is equal to minus g, because the projectile is heading upwards in the air, which is opposite to the gravity of the earth. So we can infer the acceleration due to gravity as minus g, and the t here we have x upon u cos theta. Sy is equal to u sin theta into x upon u cos theta minus g. The minus is shifted towards this, so plus minus becomes minus. Now we can write, as we have write the distance traveled in x-axis as x, similarly we can write the distance traveled in y-axis as y. So here we can obtain the equation of parabola as u and sine theta upon cos theta is equal to tan theta. Here we can write it as x upon x into tan theta and minus half g x cos theta square. Arranging these terms, we can write it as tan theta x so this is the equation of projectile motion. Now, how can we infer the projectile motion is exhibiting a parabolic trajectory? So, here we can see the y is depending on the factor of x cos theta square. If we have a relation in equation where one variable is in degree 1 and the another variable is in degree 2, so we can clarify that the path defined by the object is parabolic. So here we can infer easily that the equation of the projectile motion is this, and the path exhibited or the trajectory exhibited by the projectile is parabolic. This is all about this concept. Now let's move on to another topic. Firstly, we shall discuss time of flight. Let's suppose the object now time of flight can be inferred the total time in which the projectile was in air. So time of flight can be inferred in the way as the total time that the projectile was in air. It is known as time of flight, and the time of flight is also known as the sum of time of ascent and time of descent. We have two halves. It is our first half and it is our second half. Here the projectile is ascending in the air, and from this point where Vy is equal to 0, the projectile is descending in the air and it is heading towards the ground. So here we can discuss the time as the time of ascent, and here we can discuss the time of flight as the time of descent, and the total time in which the projectile was in air, it is known as time of flight. Let's quickly start with a simple equation of motion, which is first equation of motion. Vy is equal to uy plus at. Here Vy is 0 and uy is u sine theta, as uy is in y component, so it is u sine theta, and ay is minus t. We have studied about the reason behind it. Remember, this time t is time of ascent, and we know that the time of ascent is equal to time of descent since the path is symmetrical. We can write it as u sine theta is equal to gt. Now we have obtained the equation for time of ascent or time of descent, which is u sine theta upon g. Now as we know, 2t is equal to time of flight, 2 times of time of ascent or time of descent is equal to time of flight. So I can multiply this whole equation by the factor of 2, so I'll get 2u sine theta upon g. This is the equation which I was wanting for the time of flight. Mark this as your second important equation for projectile. In projectile we have four important equations. One is for its equation for its trajectory, one is for time of flight, another one is for maximum height, and the last one is for horizontal range. Now let's obtain equation for maximum height gained by the projectile. As we already know that the maximum height lies in y-axis, so it is better to use y-axis components, which is uy, vy, etc. So maximum height is a distance on y-axis, so I would write sy uy t plus ay t square. Now I have already learned about the equation of time of flight, so I would substitute the value of t. Here the maximum height is gained by the object in time of ascent, so here we would use time of ascent instead of time of flight, while in horizontal range we would use time of flight, because the object is attaining the horizontal range in total time t, which is time of flight, and the object here is attaining the maximum height in t, small t, which is time of ascent. So let's see, we can substitute it by h, which is given in our NCERT book for class 11. Uy is already, we know, u sine theta, and time of ascent is u sine theta upon g plus, here we have to multiply this term with half. So it is the maximum height obtained by the projectile. In horizontal range, which totally lies in x-axis, we have time of flight because the object is attaining horizontal range r in time capital T. In first second, the projectile would be at this position, and after some time the projectile would be in air at this position. But when the time of flight is over, the object would be at ground. So we would take here time as time of flight. Now let's use the components of x-axis because horizontal range r lies in x-axis. Sx is equal to ux t plus half ex t square. One of the most important thing about projectile motion in x-axis is that ex is equal to 0 because we can see there is no external force. For ideal case, there is no external force in x-axis, so we can infer that the ax is 0, and the only acceleration acting on the projectile is ay, which is minus g. So here this term is cancelled. We are left with only one term, which is ux and t. Again, sx is equal to uxt. Now let's substitute for the components of x-axis. Here we can write capital T as t. This t is capital T, which is 2u sine theta upon g. Let's substitute the whole values. Sx or r is equal to ux is what? U cos theta into 2u sine theta on g. Now arranging the terms, we get sx is equal to r is equal to, we have two u's which are multiplied, so 2u square sine theta upon cos theta on g, which is now u square 2 sine theta and cos theta upon g. Now in trigonometry we have studied a formula which is 2 sine theta cos theta is equal to sine 2 theta. So here the formula for range is u square sine 2 theta upon g is equal to r. This is the final formula for your horizontal range, and the whole concepts about horizontal range are maybe clear now, and we have an application part of this projectile motion, or the most important thing which is usually asked in competitive exams, which is Galileo in his book described that the two angles theta 1 and theta 2, which differ from 45-degree angle by same amounts, have their range equal. So let's code in it mathematical form. रेंज का फॉर्मूला होता है u square sin theta sin 2 theta upon g. It is the formula for horizontal range, and if we put the value of 2 theta, which is, suppose theta is, here we have theta what, 45 degree minus alpha, theta 1 and theta 2 would be 45 degree plus alpha. Let's substitute it in R1 and R2. It is u square. Let's keep them unchanged. Sine, multiplying them, what we get, 90 degree minus 2 theta, I mean alpha, upon g. And what is R2? R2 is u square upon g. It is sine 90 degree plus 2 alpha. Since these values are unchanged, u square upon g for all two cases, for these cases, now we know that sine 90 degree minus 2 alpha is equal to sine 90 degree plus 2 alpha. It is equal to what? Cos 2 alpha and cos 2 alpha. Since the value of sine is same in both quadrants, first and second quadrant, so we have the value of this term and this term equal. So we can infer from these equations that R1 is equal to R2, which Galileo described in one of his books, that the angle which differ from 45, the pair of angles which differ from angle 45 by same amounts have their horizontal range as equal. For example, if I have 45 degree and 30 degree which differ from 45 degree by same amount, which is that 45 minus the mode of 45 minus 30 and 45 minus 60 is equal. So the range for these angles, keeping them unchanged, the range would be equal. So maximum range attained by the projectile is when we have sine 2 theta as 90. We get the maximum range. So the theta must be equal to 45 degree to get the maximum range. This is also the most important topic, most important point of this concept. I hope you liked my video. Thank you.